History of Mathematics Week 1, Introduction and Numeration Systems. Each one of these title slides in the PowerPoint deck indicates the start of a new lecture video in this section of my YouTube channel. Hello and welcome. I'm Dr. Jack Jackson, a professor of mathematics at the University of Arkansas Fort Smith. As I'm recording this, I'm in my 28th year at the University of Arkansas Fort Smith and in my 38th year as a mathematics teacher. This course makes my 30th different course I've taught while at UAFS. I have full sets of videos available for pre-calculus, algebra, and trigonometry, introductory probability and statistics, college geometry, and the entire Calculus 1, 2, 3 sequence currently available in the playlist on my YouTube channel in addition to these videos in this section on the history of mathematics. I hope you'll check out some of these if you want to see some comprehensive lectures on these subjects. This is the first video in a series of videos on the history of mathematics. During these videos, we will provide a survey of the history of mathematics from antiquity to the present. In these videos, we will provide a broad overview of the development of mathematics, get into some details, work a little mathematics, learn some facts about people, places, and concepts, and explore some interesting stories about the men and women who developed this fascinating field. These videos will provide the primary source of lectures for my History of Mathematics course at the University of Arkansas Fort Smith. Any class time that we have may be devoted to other activities other than lecture. Before we get too much further, I want to talk briefly about some of the sources that I will be using to prepare these lectures. For nearly 2 decades, the History of Mathematics course at the University of Arkansas Fort Smith has been taught by my colleague and friend, Dr. Todd Timmons. Dr. Timmons holds a PhD in the history of mathematics and science. He has multiple academic publications in the history of mathematics, science, and technology. He was the first at UAFS to develop this course, and he continued to improve it over 2 decades that he taught it here. Dr. Timmons recently retired, and I've been assigned to teach this course. Dr. Timmons has graciously agreed to let me take full use of his PowerPoint slides and view his lecture videos. I'm making extensive use of those as the basis for these video lectures. I'm very thankful that I can make use of Dr. Timmons' education and expertise in the decades of work he put in developing quality materials for such an introductory course. Thank you, Dr. Timmons, and best wishes in your well-deserved retirement. Our primary textbook, at least for this first semester I'm teaching this course, is A History of Mathematics, an Introduction by Victor Katz. Although my students will not be responsible for everything that's in the text, they will be reading the entire textbook. A secondary text is Math Through the Ages, A General History for Teachers and Others by William P. Bergenhoff, Fernando Q. Gueva. I may assign some reading from this text. I will certainly use both of these texts in helping prepare lectures. These are the 2 texts that Dr. Timmons has used for this course in recent years. I also have a stack of additional textbooks and other history books that I have read and am reading to assist with preparing lectures. In addition, there are numerous freely available resources for the history of mathematics on the internet. And I want to single out for you one in particular that you absolutely must check out. It's called the MacTutor History of Mathematics. You can see the URL there. It is primarily put together by J.J. O'Connor and E.F. Robertson. And although others have contributed to many of the articles, this is a fantastic site that contains articles about the history of many mathematical topics. It also has biographies of nearly every prominent mathematician that we know about throughout history. This incredible resource has biographies of over 3,000 important mathematicians and over 2,000 pages of essays on over 150 different mathematical topics. If the history of mathematics sparks your interest, then this website is a good place to start for more information. A few years ago, I had the idea of creating a massive poster providing a timeline of mathematics. I ended up enlisting the help of 3 students in 3 different semesters to help with the project. They were Shaley Sanders, Hunter Marquez de la Plata, and Shanika Johnson. And they all used this as part of their senior project in mathematics, their research capstone course, as partial fulfillment of their Bachelor of Science in Mathematics degrees. The posters include a timeline from antiquity to the present. It has names, nationalities, fields, and lifespans of many prominent mathematicians. It also includes many historical events for reference and context, and has many call-outs providing a few paragraphs about selected topics in mathematics and biographies of the most influential and interesting mathematicians. There is an overview of the history of mathematics for each century, for at least most of the centuries that are there. Much of the material in the poster is repackaging of the information from the MacTutor History of Mathematics, which is definitely credited on the poster. Dr. Timmons wrote some of the callouts, and he and Dr. Kayla Murray helped edit the poster. The completed poster was mounted early in the fall semester of 2022. It spans the entire length of the hallway where we have mathematics classes at UAFS. I want to commend the students and professors for their hard work on this project. I also want to thank the creators of MacTutor for making so much useful information available to study. This timeline will be available for my students to help you along this course as well. Broad timeline. The most basic mathematics was developed by all ancient cultures as tools for solving everyday problems. By the start of the Common Era, the ancient Egyptians, Babylonians, Indians, Chinese, and others all had independently made significant advances in sophisticated practical mathematics. In particular, the Babylonians had the most significant early advancements, including the first place value numeration system and applications of mathematics solving problems in commerce, architecture, agriculture, and many other areas. The indigenous people of the Americas also made their own independent mathematical advances. However, it was the ancient Greeks that elevated mathematics to an entirely new level with their introduction of the notion of mathematical logic and proof. Greek thought, especially the axiomatic study of geometry, was widely spread through the empire established by Alexander the Great. For several centuries, the Greeks dominated the most significant mathematical advances. Meanwhile, the Indians were developing our modern numeration system, and the Chinese were also making their own mathematical discoveries with many practical applications and their own form of rigor. From the 9th to 14th centuries, following the expansion of the Arab Empire, Islamic mathematics became the dominant source of mathematical advancement on Earth. They translated earlier Greek and Indian mathematics, adopted our modern numeration system, and created the beginnings of algebra. From the 15th to the 19th centuries, particularly after the Renaissance and the Age of Enlightenment, Europe became the center for the most significant mathematical advances. In particular, the discovery or invention of calculus in the 17th century and its expansion over the next 200 years was one of the most significant intellectual achievements of all time. By the beginning of the 20th century, we had established great universities throughout the world, providing centers of mathematical discovery and learning. The United States has taken its place as one of the world leaders in mathematics in the last 100 years. Mathematical advances spurred on the technological advancements of the 18th to 21st centuries, including the ability to print mathematical results, establish worldwide travel, and ultimately communicate instantaneously worldwide. These advances have made mathematics now a truly worldwide endeavor, with significant advances being made every year by mathematicians around the globe. How old is the mathematics that we study in school? You might be under the erroneous impression that mathematics is some ancient field that is all done. This cannot be farther from the truth. It is interesting to consider how old the mathematics is that we study. New and old mathematics is scattered throughout the curriculum from elementary school to doctoral studies. However, certainly most of the arithmetic and geometry that I studied in elementary school was largely developed, but not known worldwide, prior to the Common Era. In other words, by the year 1 of the Common Era. And the algebra and trigonometry that I studied in secondary school was mostly developed by the 16th century. However, calculus and most of our modern notations for mathematics were not in place until the end of the 18th century. So prior to that, mathematics would have looked very differently, even if the content was kind of the same. Almost all of the higher level mathematics that I studied as an undergraduate was developed in the last 2 centuries, and the mathematics that I studied in graduate school was nearly all developed in the previous 100 years. And the last part of my PhD, my dissertation, of course, was completely new mathematics developed by me up to the day I finished my research. So mathematics is an ever-growing and expanding field with new mathematics being discovered, created, developed every day. The rate of growth of knowledge in mathematics has happened throughout history at an ever-increasing rate. There are now today more professional research mathematicians creating new mathematics than at any previous time in history. Mathematics educators are continually working on new ways to teach mathematics, including my use of these video lectures to communicate to a potentially worldwide audience. We cannot emphasize enough that mathematics is a dynamic, ever-expanding field with new results and concepts being developed daily. Mathematicians developed mathematics. That is, people developed mathematics. By its nature, it's easy to teach mathematics in some kind of finalized, polished form without reference to the many years of work that went into discovering or creating it. On the one hand, this is great because we can focus on the most efficient way to get students to learn the most polished form of the mathematics that we need to learn. On the other hand, this is quite unfortunate because we often don't explain how there was a long process of discovery of the mathematics that today some of us often take for granted. We often lose the heart of mathematical discovery when we see it this way. Real mathematics is really more about the process of discovery than it is about the final result. Just as bad, we often neglect to mention the mathematicians that work so hard to create and then share their work, without whom we would not have had any of our modern conveniences. Mathematics has a long and interesting history with many extraordinarily brilliant men and women advancing the frontier of our knowledge, along with many more ordinary mathematicians who make smaller contributions, and hosts of scientists, engineers, and other professionals who use mathematics in many fields. These people all had interesting lives, each with their own challenges and triumphs. We all benefit from the societal and technological advances that mathematics has made possible. Mathematics is truly a multicultural, universal intellectual endeavor, developed by men and women across time and space. This course and these lecture videos should give you at least an overview of the development of mathematics over the last 3 millennia, along with some glimpse of some of the people who have contributed to this remarkable field. History and mathematics classes. At this point, and as you are going through this course, consider the following questions. How often in your mathematics courses have you studied any about the history of mathematics? For what topics do you know the creator of the mathematics or the top contributors to the field? Even if it's named after a mathematician, sometimes that is not the initial creator of the mathematics. In our textbooks at UA Fort Smith, we often have little historical things in the textbooks. In fact, most of them do. Often they're in little sidebars. How many of you have read those? Did you find them interesting? If you're planning on going on to be a mathematics teacher, how could you incorporate some history of mathematics into your lessons? Could this make the topic at hand more interesting and engaging for students? Or would this distract from time spent on learning the mathematics itself? What is a good balance? Is mathematics an art or science? You will sometimes see this debated. If you ask most people, they will agree that mathematics is a powerful tool for solving practical real-world problems. It is certainly true that many mathematical advances, particularly the earliest ones, have been in response to solving some practical problems. Mathematics is one of the most practically applicable fields of knowledge. It has been referred to as the queen of sciences. Unfortunately, mathematics is often viewed as merely a collection of algorithms. That's an Arabic word for a process. Although mathematics certainly includes many algorithms, it is in fact ultimately much more about problem solving and logical thinking. And for this reason, it is a critical piece of any good education. Graduates who are armed with good mathematical skills are much more valuable to employers, making them more employable and better employees. So mathematics is a practical science. However, mathematics is not only a science. At its highest level, mathematics is also a beautiful art form. Much of the mathematics exists for the same reason as any form of art. Why does a painting or a piece of music exist? It is because the work of art has its own intrinsic beauty. It satisfies some creative, expressive need of its creator and can be enjoyed by others. Much of mathematics is the same. Some of the most beautiful mathematics exist for its own intrinsic beauty without regard to any practical application. Ultimately, mathematics is both an art and a science. Is mathematics discovered or created? This is actually another area of some debate. On the one hand, some claim that mathematical structures and concepts are already there and that mathematicians discover them. There is evidence to support this view. Many basic concepts, such as the natural numbers, using some basic numeration system and basic operations, were independently discovered by all known primitive cultures. There's reason to believe that if intelligent extraterrestrial life is ever discovered, they too would have these basic concepts. And mathematics is built on the foundation of previously known mathematics. Even Sir Isaac Newton, one of the top mathematicians of all time, said that if I can see farther than others, it is because I stand on the shoulders of giants. Sometimes the time is ripe for the discovery of new ideas and tools, as evidenced by the simultaneously and independent discovery of calculus and non-Euclidean geometry by multiple mathematicians. It is certainly true that much mathematics is discovered by working within established mathematical structures. For example, my PhD dissertation involves solving a problem in finite group theory. As with any original research, my results are completely new to the world at that point. However, the question I answered was one that anyone could have asked that knew the structures that I was studying. I was simply the first to focus enough effort on that particular question to find the answer. I would say that makes my dissertation more discovery than creation. On the other hand, we can easily argue that all of mathematics is really a collection of abstract ideas that were created by men and women. Certainly, there have been times when someone has had such a creative insight that entirely new mathematical structures were created. It's hard to argue that these things were merely discovered. Without doubt, all new mathematics is developed by a creative process. In fact, the first time that any individual solves a problem or discovers a mathematical concept, even if it has been previously found by others, it is a creative process. So I think that there is ultimately plenty of creation, discovery, and development in mathematics. As we continue through these video lectures, we hope that you'll come to see that mathematics is a beautiful, dynamic, human, intellectual endeavor that has a rich and interesting history. Check back, especially through the fall semester 2022, as new videos are added to this section of my YouTube channel.